Okay. We look to be good, so. Okay, you guys ready? So we're going to look at, we are going to look at the application of percent worksheet. Okay, we're going to start that this week and finish this. So there's going to be some number crunching, and it's still a continuation of your word problems. The first thing we want to talk about, though, is percents. If you guys remember, what's the definition or meaning of percent? So if I put over here, what does percent mean again? Right? Per, and I'll write it this way. Percent. Okay, do you guys know what the meaning of per means? If I said I'm going to give you $5 per person. Okay, so we got this per. I just want to say per means to divide. By the way, it's a rate. $5 per person is a rate. And this cent comes from the word what? Cent means 100. So that's why you see a lot of words that use this cent concept, like century. How many years is a century? 100 years. How many? What about the word cent in terms of money? Right? How many cents are in a dollar? 100. So this concept of percent is divide by 100. We have a symbol in mathematics, what's called the percent symbol. This is the percent symbol. Okay, but it makes no sense in terms of a numerical value unless you give it a number in front. Okay? And so for example, they may say the definition of n percent is, oops, sorry, wrong class. It's n factorial. N percent is n divided by what? 100. You okay with that? This is the per what? Cent. And then that's n over 100 because we're divided by what? 100. So n percent, ladies and gentlemen, if you guys remember, this is the meaning of it. Okay? So that's one part of this. So if you look at this question, to write this as a decimal, first of all, you're reading 3%. So right off the bat, you think 3 divided by what? 100. Are you guys okay with that? In fact, each of these is going to be 12 now divided by what? 100. And then you got 65 divided by what? 100. You got 128 divided by 100. You guys okay with that? And you got the 13.2 divided by 100. 5.5 divided by 100. So we're using the definition of what it means to be a percent or n percent, but that's really not what they're asking us to do in the question. Is that true? What are they saying to do? What do the guys want you to do with this? To convert it to a what? A decimal. So if you guys remember, for example, 3%, if I wrote it over here, okay, 3 divided by 100, what that looks like in long division is this. That 100 is going into the 3. And so if you guys remember, bless you, if you guys remember, 100 doesn't go into 3. So you're going to have to put your decimal here and put a 0 and determine, does 100 go into 30 now? No. Does 100, what do? Add another decimal. Is that right? So 100 goes into now 300 how many times? 3. You put the 3 under that last 0. Don't forget your decimals up here. So now 3 times 100 is that 300. Subtract, you get what? 0. You have this answer of point with a blank space and 3. But what do you guys remember? What do you put with the blank space? 0. Good. So the moral of the story is 3 over 100 as a decimal is really what? 0.0 what? 3. Okay? So let me say this. Let's recall or let's note. There is a what? Shortcut. Now, by now, you guys should be really well versed with the shortcut. Does anybody know what the shortcut is?
Multiply 0.01.
Well, what is it?
Multiply 0.01
Multiply 0.01?
by 0.01.
Oh, multiply by 0.01? Oh, that's interesting. That actually works, I think. But what I'm talking about is, if they're talking 3% now, right? You see that number 3? Where's the decimal behind any whole number, like a number 3? Or where's the decimal at? Good, I actually said it's behind it, right? So it's right here. You guys okay with that? Now when you convert this, here's what I'm going to say to you. You know that decimal is here. Okay? The shortcut is that you move the decimal how many spaces? 1, 2. 2 spaces to the what? To the left. And fill in the blank with a 0. Now the reason you do this is because this is really the effect of dividing any whole number, or really even any other decimals, by 100. In Math 110, when I go through this in detail, we go through dividing by 100. Maybe you guys took the class. Did you guys ever take 110? Right? Did they go over all the, make you divide by powers of 10, divide by 10, divide by 100, divide by 1,000? And you always move the decimal to the left, the number of zeros you have. So if there's 2 zeros, you move that decimal 1, 2 spaces. Fill in the blanks with a 0. In other words, this was the shortcut of writing. You could now say 3% can be described as 0.03. We do put a 0 very often if there's no whole number here in front of that decimal point. So 3% will be 0.03 as a decimal value. Bless you. Okay, you guys okay with that? Okay, you're with me on this? So we're going to have to use the shortcut. In other words, I know you know the definition. Here's the definition for each one. They didn't ask you for that. They asked you for the decimal. So I'm going to assume you guys are all Math 110 ready, or yeah, what is the word I want to use? Suave. You could read my mind, can't you? I wanted to say that. Tell me, what am I writing down since you're Math 110 suave? What are you going to put down? You're going to say, 0.03. And you're going to say, what's 12%? 0.12. Okay, good. What's 65%? 0.65. Okay. What's 128%? 1.28. Good. And then what's 13.2%? Point what? 0.132, good. And then what's 5.5%? 0.05 what? 5. What about 8.92%? 0.0 what? 0.0892. You guys okay with this? And then what's 125.8% going to be? 1 point what? 258 numerically. And what is 0.05% going to be? 0.05? 0.1%, what's that going to give you? 0.00 what? 1. Anybody have any questions on any of these here? Everybody's okay with that? Can I ask you a question then? What's the purpose of us actually converting to a decimal? Why do we care? Why do you care about making that a decimal? Easier to work with? That's a good answer. Yeah, like for example, let's say, for example, what are you guys going to go out and buy today? Anybody going to buy anything today? You're going to go buy a nice sweater? Why are you going to buy a sweater when the temperature is 100 and something degrees?
It's going to get cold.
Huh?
Eventually it's going to get
Oh, eventually? I don't know if that's going to happen because Every time I get hope, my hope is dashed. It was hotter yesterday than it was in yesterday in LA. It was hotter here. How hot was it yesterday?
100 degrees.
I think it was a little more. It might have been a little more than 100. Was it 108 yesterday?
It was the highest was supposed to be 108, the lowest was supposed to be 100.
Yeah, it depends on the location. But it was hotter, I think it was hotter around here than it was in Las Vegas.
Wow.
Anyway, let's buy our sweater. How much is a sweater going to be? Let's buy a sweater for 100-degree temperature. If you purchase a sweater, ladies and gentlemen, here's why you care about some of these things. This is why we use this numerical version. If you buy a sweater, how much is your sweater going to cost? Let's say the sweater costs how much money? $65 for a sweater? Ooh, it better keep you what? Let's say it's $65. That's going to keep you warm. And let's assume you have I hate to break the news to you, don't you have to pay sales tax? Okay, we're not going to be accurate. Let's say the sales tax is 8.5%. Here's the question now. The question becomes for you, how much is your sales tax? Now, sales tax again is a dollar amount. Do you guys okay with that? Isn't that an amount of money? But then you said, but wait a minute, you just got through telling me sales tax is what? 8.5%. Well, this here is the sales tax what? That's the tax rate. You say, what are you talking about? It's a tax rate. Yeah. 8.5%, isn't that 8.5 per what? Per 100? That's a rate. So if you know the sales tax rate, you can deduce the sales tax what? Amount in money. In this case, dollars. Okay, so there's a way to do this. I'm using this as a preference here for our work that we're going to do for review stuff. So anybody know, how do you actually determine that sales tax amount, a dollar amount? There's a relationship. It's a fundamental relationship you guys really want to be aware of. Why would you guys be aware of this? Don't you guys go shopping? Right? You're going to go buy an Xbox. Right? You're going to go wherever. Don't you have to pay sales tax? All right, so you guys want to know how to do this? Sales tax, the amount, is going to equal the what? The sales tax rate. Okay, so this is the sales tax rate. This is for the amount times what? Times, you could say times there's a lot of words we use here. Times the cost, the original amount, the purchase price. We use purchase price? Let's call it the what? The original amount. So that fundamental relationship we have to remember how to work with. It's back. And we're going to see how it's really back. Okay, so you got the sales tax amount. So this is how you could determine your sales tax forever. What changes is the what? Is the rate. So here's my point. If I have to find the sales tax in terms of the amount, okay, I need to know the rate. I do. I need to know the cost, the original cost of the item. How much is your sweater? 65. So your sales tax is based on the cost of your sweater. Do you guys know that, right? So what do? You take let's see, if we're going to compute this. All right, let's go back here. How about if I erase some of these decimal values for you? Okay, so if we compute this, the reason they want you to write every percent as a decimal is because when you use this, the sales tax is, as an amount, you don't say, well, it's 8.5% of what? The $65. You okay with this? Look, pay attention to the language I used. Your sales tax is 8.5% of what? 65. Do you guys know what the word of is in the context of percent questions? Good. You guys remember? This means what? Multiplication. And so if you went through and said, do I multiply 8.5 with the 65? The answer is a big what? No. You're going to get some huge number. Okay? So in other words, even though we communicate to each other in terms of percent, we're talking about a rate. We have to convert that percent rate to its numerical what? Representation. It is 8.5 over 100 by definition. But as a decimal, what is this? We move it how many spaces? Remember, here's 8.5. Move it 1, 2 spaces. Plug a 0 there. So this is 0.085. This is the decimal representation of the 8.5%. This is what you use numerically in your calculations. Always, always, always. Okay, you okay with that? You always use the numerical representation. Now, could you use the fraction? Yes, you can. But typically we use the what? The decimal. And that's the number that you put here. You got 0.085 times what? 65. There's arithmetic to perform. Okay, so a big part, believe it or not, of what you guys have to be able to do is what? Arithmetic. So how do you do this kind of arithmetic? Do you guys remember? Yeah, okay. There's a whole course in this, right? 65, we got 85, we got 0. Okay, you're going to multiply now. You go through essentially your algorithm for multiplying with decimals. That's what it is. It's a decimal multiplication algorithm. So if you guys remember, you go through this. 5 times 5 is what? 25. 6 times 5 is 30, plus 2 is what? 32. You okay with that? And then what else do you do? 8 times 5 is what? 40. 8 times 6, or 6 times 8 is 48, plus 4 is 52. Here's 2, here's a 5. And then you say 0 times 5 is 0. 0 times 6 is 0. You add your values. And then you go back and you say, well, there's a decimal here. You have to count, if you guys remember, how many decimals or how many values here to the right of that decimal. 1, 2, what? 3. Do you guys remember the final step? Behind this whole number, 5525, 5,525. Move that, the number of spaces, or the number of digits to the right of your decimals. Here there's only one decimal. So you have, what's this final answer? 5.525. In other words, your sales tax, ladies and gentlemen, the sales tax is 5.5 to what? 5. There's a problem here. What's the problem? What do you think? What does it go to? What do you think? Do you guys remember, is there such thing as, if you look at a receipt, is there such thing as $5 and, what is this? 525 thousandths of a dollar? 100 thousandths? Yeah, 525 thousandths of a dollar? Is there money that goes out to that third decimal place? Say you've never seen it. Why have you never seen it? Because there is no money that goes out this far. Where does your money go out to in terms of a decimal? It goes out to the tenths. It goes out to the what? Hundreds. Did you ever look at a receipt? You sure? That's approximately what? $5.50. You have to approximate to the nearest hundredths. So what does that mean about the 2? You look at this digit. If this digit is a 5, 6, 7, 8, or 9, what do you do to the 2? You add 1. So this will be approximately $5 and what? 53 cents. In other words, this here is the sales tax. Okay? You okay with this? So your $65 sweater isn't going to be $65 in total. You have to include the what? The sales tax. Okay, so do you guys know? This is the answer to the question, by the way. Your sales tax is $5.53. So sometimes when you work with the money questions in the book, you have to go out to the nearest penny. Okay, you guys okay with that? So you're going to estimate. They didn't tell you, hey, approximate to the nearest penny. But that's what you do, because that's what you'd have to do if you purchased a sweater that was $65 and if the sales tax rate was 8.5%. Okay? That's what those registers do on their own, is they approximate to the nearest penny. Okay? So anyway, here's the deal. What do you think comes next? Let's note. What do you guys always include? What do you think? What should we call this? The total is equal to what? The original amount plus or minus. What is it? Plus how much? The sales tax. Do you guys believe that? Is that really how this model works? Is that how the real world works? So the real world uses addition?
Yeah.
Did you guys realize that? In the real world, there's mathematics. Oh, isn't that horrible? In the real world, there's math. Darn it. Anybody go to the Dodger game this Sunday, Fan Appreciation Day? You know they gave away a car. Do you guys know that? They gave away a car. Who won the car? I don't know. I'm glad it wasn't me, though. You know why? Because you have to pay the sales tax on the car. Do you guys know that? You got to pay the sales tax. I think you got to pay. That's what I heard. It might be wrong. So if you didn't have enough for the sales tax, what do? You don't get the car, I guess. So I should raffle off a car here every day. But remember, I have to make you pay the sales tax. I should raffle off like a Mercedes or something. $100,000 Mercedes. Have you come up with the sales tax? You'll match it? All right. The real world has addition. What was the original amount? 65 plus $5.53 in tax. You're going to have to use another algorithm to add with decimals. What is the total? What do you guys get? $70 and what? 53 cents. So ladies, you're not going to be able to walk out of that store with that sweater unless you give them what? Not only the $65, you have to give them an additional $5.53. An additional sales tax is what they're saying. You have to add some money to that. So this fundamental model exists. It's a very basic model. There's a few models we'll talk about. But this is kind of, first of all, why you're going to need to do what? Convert every percent to a what? Decimal. Okay, because when you use them, very often you're using the numerical representation. We also use the fraction representation at times, but you know, numerical is pretty much kind of the way to go. All right, you guys remember this stuff? Because it's back. And it's going to be back with a vengeance. So, all right. Anybody have any questions on what we just did? Yes?
You said that sometimes you use the fraction.
The fraction form, yeah.
When is that usually considered?
Well, it's going to come up next. Some of the questions we work on, sometimes it's easier to do things with the fraction than it is a decimal. So it's a matter of picking your poison. you may sometimes you may have to pick a headache, or you have to pick a what? Stomach ache. So if the headache is the decimal, sometimes the fraction will be the stomach ache. You still have to do the work. So you're going to see what we're talking about, which one might be easier. It's when the computations are nicer to do. Okay? All right, you guys okay with that? So I warmed you up here with us. You guys now nice and warm? Or is it, well, you're probably cold in here. You're cold in here, but you're also hot where? Outside? I think it's back to being beach weather again. Am I the only one that goes? I must be the only one that goes to the beach. Am I the only one that goes to the beach? You guys are playing Xbox or something at home? No? We're the Xbox players here. Oh, jeez. Is that right? You rather play Xbox than go to the beach? Yeah. Oh, are you serious? Wow. I'd rather go to the beach. Wow, I'd rather go to the beach than play Xbox. Huh? I'd rather go anywhere than play Xbox. No? You guys you rather go to the beach? Huh? There's no time? All right. Let me say this to you guys. I'm glad you said there's no time. That means you're doing your homework. So I'm going to say we have 3 types of questions. There's 3 types. So let's review here. Let's review the type of questions that we actually have here. Let's do the easy ones first. How's that? You guys want to do the easy ones? How about this? This is your first type. I'm going to say, what is n% of a triangle? This is what I call type 1 questions. Okay? Let's put a square just in case. Okay? And here's the second question. Type 2. Let's go with our type 2 here. Sorry, you guys got me thinking of the beach. How if they gave you n% of triangle is square? That's a type 2. Here's the type 3. What percent of triangle is square? These are all questions. Let me translate a little bit of this for you. When you see the word is, what do you guys always want to think of? Equal. You okay with that? So when you have the word is, there's an equal. So this is consistent with what you guys already know. And what about the word of? You guys, of means in this context now what? Multiplication. You okay with that? Now, if they say to you, what percent, you don't know what percent, right? You could use X, but be careful. It has to be percent. So you're going to use the percent sign. And what, you don't know the value. So use a letter, we've been using N. It's like saying what number. So this here is similar to the phrase, what number. So you're going to use N to describe that. You okay with that? Over here, they're saying, again, what is short for what? Number. Okay, let's look at these examples of those. I gave you examples of all three types, okay? So each one of these problem sets is going to be really one of these three types. And that's what they do. They give you the same type, or they got three different types. They test you on whether you could do the mathematics. But first you have to translate it. Okay, so let's go through the translation again. It says what percent? So what do you guys know? How do I describe the phrase what percent? Well, good. That what is short for what number, percent. So you're going to say, and what? Percent. Good. What about the word of? Good. Multiplication. Times. Times what? Times 76. What about the word is? Good. This is my equal, right? And what does it equal? 19. So everybody okay with that translation? So what you're going to have to do is go through these homework questions where they translate that phrase, what percent. All of those questions are of this type. They look like this. Remember, there's three types. Notice, did they give me two values and ask me to find the third? They sure did. What about this one? Let's translate this. They're saying 12% of what? What number is 0.3? What do you notice? Is means what? Equal. What about this phrase, what number? Do you know the number? Call it n or x. What about the word of? Times. This means times, right? And then you got 12% here. So you got 12%. So I'm going to write this down. We have 12% times n equals what number? 0.3. Notice again, what did they do? They gave me two values. They said find the what? Find the third. That's the name of the game. They're going to give you two. You got to find the third. But notice, is that the same as the prior question? No, they said what percent? That's n percent. And then what's this? Just n. There's no percent. It's a number. Good. So look at these two models. They're different. This is going to be yet a third different model. Okay, so let's see. What does it say? 24%. I know what that looks like. It's 24%. Oh, what does of mean? Times. So there's times. And then you got the phrase what? What number? Do you know the number? Good. We're going to put that as an n. What does is mean? Equals. Notice. You got n, and that equals what? 54. Okay? Notice yet again, they gave you two quantities, and you got to find the what? The third. You okay with that? Okay, you guys ready to do the algebra now? What you do now is you solve for n. So in some ways, you could just do the algebra. Can I erase all these phrases here for you? We do the algebra now? Okay, so take a look at your phrases, take a look at your notes. It's time for the algebra. Well, let's do the first one. Do the algebra over here. So the first one, what do you guys notice here? For the first one over here, let's use our scratch board this way. I got n% times 76 equals 19. What's the meaning of n% again? What's this definition, by the way? Isn't that n over what? 100. You guys okay with that? And then this will be times 76 equals 19. Because in each case, they want you to find the number. Or find the value of n. All right, here we go. What could we do here? There's a couple of things. Algebraically, this kind of looks like, well, this is a fraction multiplied with a whole number. Is that right? So how do you multiply a fraction with a whole number? Don't you multiply straight across? You guys know what I'm saying? 76 over 1. Don't you multiply straight across? So in some ways, we can write this as 76n over 100 equals the number 19. I know we have n times 76, but we like to put the number before the what letter. And we can change the order in which you multiply because the order doesn't matter. Then 100 times 1 is still what? 100. You okay with that? I can also say this is 76 over 100 times n, just like all the other problems that we've been working with. You with me on this? You guys okay with that? All right, what comes next? Could you guys solve for n? How did you guys solve for n in that first test? You multiply both sides by what? By the reciprocal of what? 76 over 100. Is that true? So you took the fraction 76 over 100 and being 19, what you did in that first test is you multiplied both sides by 100 over 76. This is times 100 over what? 76. What's the benefit of multiplying both sides by the reciprocal here? This goes away. Is that true? So you now have n equal to 19 times what? 100 over 76. That's 19 times 100 over 76. So be careful. This is a whole number, again, times a fraction, and how you multiply is straight across. Okay? Put that as 19 over 1. As you guys can see, what happens now is some arithmetic. What's 19 times 100? That's 1900. We have to divide by what? By the 76. You guys okay with that? Here we go. Where do we put our division at? We're running out of board space. Yeah, where do we put this? How about if I do this? What should we do? Everybody okay with the fact that I have to divide 1900 with 76? You guys have that in your notes? Okay, well, let me do this then. I'm going to have to erase a little bit of the work. 1900 divided by what? 76? Is that what it was? Okay. 76 goes into what? 1900. We have to do some arithmetic. Does 76 go into 1? No. Does it go into 19? How many times does 76 go into 190? I think it's 2 times. Is that right? Is it 2 or 3? 2. What's 2 times 76? Is that 152? Okay. Double check. Is that true? All right. This is an 8. Okay, so we get 8. What is that? 3. Bring down my 0. How many times does 76 go into 380 now? How many times? Is it 5 times? How do we know? How do you guys really know? Just try it out. I mean, if you take a guess and you go, oh, I don't know, maybe 4, no, maybe 6, try 5. Isn't that what you have to try to do? What do you guys think? Were you born knowing those right answers? Did you guys know a math trick? None of us were born knowing those what? Right answers. None of us. Even me. So what did I have to do? Yeah, I had to try, okay, maybe once, maybe, no, it's more than once. 2 is 152. 4 would be double that. So that's about 30 something, right? Maybe 5, so I take a guess. Let's double check. 6 times 5 is what? Is that 30? 7 times 5 is 35. 36, 37, 38. Sure enough, what did you guys notice? It is 5. So it's 380. Is that a remainder of 0? You guys with me on this? So n is the value what? 25. What was the question? What percent? In other words, the answer is 25 what? Percent. So 25% of 76 is the value 19. So ladies and gentlemen, cancel that Xbox for this weekend. Get rid of the Xbox. And what are you going to do? I got news for you. dividing 1900 with 76 will take you a lot farther. Then you could buy 20 Xboxes. But if you can't do that, you can't buy any Xboxes then. You know, so you guys want to do the division. 1900 over 76 is 25. So you do have to break out some of these skills, okay? And I know that's where people go, why do I have to do this? Because math is where? It's everywhere. Everywhere. You okay with this 25%? Anybody have any questions on this? No, you guys are good with that? Do you guys know even the programmers that actually program that video game, they have to know what? They got to know math. Why do you think they have to know math? What's your favorite video game? What's your favorite back there? Call of Duty? Why do you like Call of Duty? It's pretty realistic, isn't it? Do you guys know when those explosions go off, if they're not realistic, you're probably not going to like the game? Do you guys know that? So that programmer has to be familiar with math and science to make it really what? Real. Gravity has to fall the same way it does in real life, you know? So that's what programmers actually do. They do work with the science behind things and make it as realistic as possible, and that's where the math comes in. So if you wanted to be a programmer, and some students do, they want to be like these programmers for video games, right? Then yeah, you got to take a lot of math and a lot of what? Science, and then program. You put it together. So it works. So even if you wanted to be a video game programmer, which you can, you're still going to have to know the long division. I know what you'd rather do. You want to be the professional video game player. Is that right? Put in an 8-hour day playing video games. Do people like that exist? Does that job kind of exist?
Yeah.
Do they?
Yeah.
Really? Man. I'm doing the wrong job. What am I doing then? That really exists? I just made it up. I didn't know that exists. But are those guys happy?
Yeah.
They are?
Yeah.
Are they really? I didn't know that. They have to be very good? Are you serious? A lot of practice, huh?
They work like once a week or something like that.
They only work once a week?
I had a friend that did that.
She did that.
I don't know how much she was getting paid, but she was working like once a week or something.
You know, if you're only working once a week though, chances are you're not going to get paid very well.
I heard she was getting paid very well.
Oh, that's relative. What's being paid very well is relative. Do you guys know that? For kids, you might say, oh, that's enough for me, but you're living where? Where are you living? At home? Who else is really paying the bills? Your parents? You guys see what I'm saying? So for some kids, they go, man, that's enough money for me. Well, is it enough for you to what? Get married? Have a child? Pay all the bills like your parents? Then it may not be enough. It's relative. So yeah, so be careful. If you work once a day, I'm willing to bet, unless it's like, you know, that Facebook guy. He invented Facebook. He really ripped off some other people, but oh, we're on video. That's in the courts. He stole an idea and he didn't, you know what I mean? Unless you're that guy, working once a day is probably realistic. Then for him, who cares? He works once a day. He has all that money. But chances are, if you only work once a day, that's not good. It's not a good thing. You got to work every day, or 5 days a week. How do you answer this question? Do you guys know? What's 12% look like?
0.12.
Good. Is that 0.12? So you're going to get what? 0.12n is 0.3. All right, you okay with that? And then you divide both sides by what? 0.12. Notice what happens with the 0.12. Is it gone? And what do you have left? N is that 0.3 over 0.12. So you're going to have to now remember the algorithm of division with decimals. Oh, geez. You guys know what I'm saying? Anybody remember that algorithm? Math 110, I show those Math 110 students. What's the algorithm? Huh?
The amount of times you move the decimal to the right.
Well, you're going to look at this decimal here. What you want this to be a whole number. Remember that? It's not a whole number. So what do? You're going to move this decimal 2 spaces to the right, because that now makes the 12 a whole number. You with me on that? So then you really have this 12 here. And then, if you move this decimal 2 spaces, you move what? This decimal 2 spaces. But then you're going to say to me, what do I do with that blank space? Put a 0. What number is this? Do you guys know? Yeah, it's really the number 30. I know there's a 0 in front. Who cares? It's still 30. So, ladies and gentlemen, this problem really becomes 30 divided by 12. Or 12 going into 30. You okay with that? Look at that. And the decimal's out here. Going out here. 12 goes into 3. How many times? It doesn't. 12 goes into 30. How many times? How many times? 2 times? What's 2 times 12? 24. Subtract. What's 30 minus 24? 6. Bring down the what? 0. 12 goes into 60. Bless you. 12 goes into 60 how many times? 5. 5 times 12 is 60. Subtract. Ladies and gentlemen, you have your answer. What is n going to be? N is 2.5. So, out here, 12% of the number 2.5. This is what n is. It's 2.5. 12% of 2.5 is 0.3. Okay, and all of these have applications, which is why we're going over these. Okay, you've done one, you've done them all, but don't just do one. You have to practice this until you're very good at it. Okay, like the Xbox, you got to practice until you're very good. What about this last one? That was number 3. I'm sorry, I'm out of order here. So we did 1, we did 3. We're now going to do what? Number 2. You guys ready to do 2? All right, here we go. Wow, this is pretty similar. Did I mess up? I did. I have to give you another third type. Oh, this one's similar. Sorry. This isn't even a type 3. There's not 3 types. This is just like this is like the one we just did. All right, let's take a look. What's 24% anyway? I'm going to have to videotape the next class. We might as well turn off the camera. No? Should we just keep this? Yeah, let's keep all the mistakes. It's not perfect, but that's okay. That's how you learn. It's not perfect. Here we go. 24%. How do you write 24%? Isn't that 24 over 100? Or point what? 24. So ladies and gentlemen, we have 0.24 n is 54. Divide both sides now by what? By the 0.24. Oh, this is a pretty good one. I see why this is good. That's fine. Now what do you get? You get n is 54 divided by what? 0.24. So again, we have another division problem. We got 0.24 going into what? 54. When you divide, you need a whole number out here. This is the algorithm. If you don't have a whole number, what do you do?
Multiply by 100.
Well, I'm going to say move this decimal where? You're going to have to move it 2 spaces. Why 2 spaces? Because that's the number of spaces that's going to put the decimal behind the number. So you get a whole number. So you got 24 now, okay? Goes into, here's the decimal.
Sorry.
It's all right. You move it what? 2 spaces, right? And what do you put in here? A couple of zeros. So that's really 5,400. I kind of like this problem anyway. See what making a mistake can do to you? You guys see that? Just because you made a mistake doesn't matter. You get a different variation. You get a different, it's the same type of problem. Maybe you were wondering what you do in that case. So now let's go through the division. 24 doesn't go into 5. 24 goes into what? 54. How many times? 2 times. What's 2 times 24? 48. What's 54 minus 48? 6. Bring down the what? 0. 24 goes into 60 how many times? 2. 2 times 24 is what? 48. Subtract, you got what? 12. Bring down the other 0. 24 goes into 120 how many times? 5. 5 times 24 is 120. Subtract. Ladies and gentlemen, n is what? 225. Okay, so the number they're talking about is 225. So if you were to take 24% of 225, you know what you get? $54. In other words, you imagine if the tax rate was 24%. And your sweater was $225. Is that a nice sweater?
No.
No? That's a nice sweater.
Maybe.
What's the tax on $225 in that case? 54 bucks. Whew. You guys see what I'm saying?
That's another sweater.
Is that a nice sweater?
I said that's another sweater.
It could, that's a keeper. I like that. You know how much okay. That's almost another sweater. So you can buy this sweater. The tax is another sweater at the other store. You guys know what I'm talking about? We got time for the third one, right? That's another sweater. I like how you guys could deduce that. You know why? Because this is what mathematics is. It has a lot of value. Let me make sure I give you the third type here. So let's leave these 2 up. Let's call this question number 4. All right, no big deal. 12% of what number? 12% of what percent? What is that? 20% of what number? Oh, I know. We have to do an easy one. We have to do an easy one. You guys want to see it? This is what they want you to do. We probably shouldn't even call these number them anymore. They're going to say, what number is 2.5% of 30? This is different than the prior examples. This is really the third type, okay? So what I want to say to you is there's 3 types to do. All right. You really have 3 flavors of the same thing. Fine, whatever. Here we go. You guys ready for this? What number is what? 2.5% of 30. So if we translate this, what's the key word here? Is. That's equal. Is that right? What number, what do you replace that with? N. Is that right? So far you guys know I have replaced what number with n. Is equal. You have n equals, what's this? 2.5%. What does of mean? Multiplication with what number? With 30. This is the easiest one. So I left the easiest version out. Okay. I should have never looked at your book. I should have just done it by memory. Who cares? 2.5% of 30. Well, what do you guys know again? How do you represent 2.5%? What is this? 0.025? Isn't that what it is as a decimal? So then n becomes simply 0.025, right, times the number what? Times 30. So notice, what does this mean now? You bring out your algorithm of multiplication. Do you guys remember how to multiply? I'm going to do the decimal this time first and put it on top. Remember your decimal algorithm multiplication? You got to get that out. 0 times 5 is 0. 0 times 2 is 0. Oh, these are more zeros. 0 times 0, 0 times 0. 3 times 5 is 15. 3 times 2 is what? 6 plus 1 is 7. 3 times 0 is 0. 3 times 0 is 0. What do you get when you add? 0, 5, 7. There's a bunch of zeros here. Do we care about these zeros? Not really, but let's check. What's the last thing we have to do? I got 1, 2, 3. 1, 2, what? 3. Is that true? Double check. What number is this? N is point what? 0.75. Is it time to go? Is it really? All right, I'm sorry, I kept you a little. N is 0.75. So if I were you, I'd get started on what worksheet? The application of percent worksheet. The first 8 are of these 3 types. Work on those. Also, in your book, 2.4. Try 19 to 60 odd. Actually, sorry. You're going to do 11 to 60 odd and 2.4. So 2.4. Well, I know it's 11 to 59. Let's do that. Odd. And do the worksheet called application of percent. Okay? All right, we'll see you guys tomorrow. Okay, we're going to begin. Okay, so we're working on the applications of percent worksheet here. And number 9, you guys know we have bill. In that worksheet, you have a bill supposedly for a total of $411 that went to some city services, 95 of which went to the high school district. So they're thinking of this here as the total, $95 went to the high school district. They want to know what percent went to the what? Went to the high school district. Okay, so what do you think? How do they go about this? How do you go about finding what percent went to the high school? When you know $95 went to the high school. Do you guys know? Say that again? Yeah, it is going to be the numerator. You're right. So let me go through this with you guys, because these two are the kind of warm-up problems that we're going to work with today. That, remember the model, n% of some amount equals some other amount? Okay, so they're taking some percentage or some portion of an amount equals, some value here. So if you really look at this statement, you can kind of say n% of how much money? 411 good should be what? $95, okay? And so what that does for you is it gives you an idea of how to approach this algebraically. So you got n% times 411 equals 95. Now remember, they're asking for now what? What percent? So yesterday we went through the 3 different types of scenarios. This is one of the types. This is the type that asks you for n%. Okay, you guys okay with this one? Now, I did the algebra here using the scenario n% of some value equals another value. So if I multiply this is multiplication of the triangle. If I undid the multiplication, I have to divide both sides by what? By that triangle. In other words, you're going to have this relationship. Okay? So if I go through the algebra that we did yesterday here, right, this becomes again n% times 411 equals 95. What would you guys do again here with this? Let's do the work over here. You're going to translate. What's n% times 411 equal 95? You're going to divide both sides by what? By 411. Okay, then you get your n% being what? 95 divided by 411. Okay, so n% is going to be numerically. Now I did this work. Some of you guys know I did this work last night watching the Dodgers lose. So I did all this work. I gave my work to a gentleman in the earlier class. So number 9, what I got last night was 0.2311. Okay, doing the arithmetic. And this is actually what? N% is 0.2311. This is a percentage. But what percent is this numerical value actually? Do you guys know? Well, what's the meaning of n%? What did we say yesterday? N over what? 100. Is that right? So I'll put some work up here that n over that 100 would be 0.2311. We might be running out of space here. Well, what do you guys know? What do you do with this? Let's put it down here. N over 100, 0.2311. If you solve for n, you got to multiply both sides by what? By 100. So what's the effect? If I multiply that left by 100, and I multiply the right by 100. Right? Remember, this was n over 100. You get n to be what? 23.11. So 23.11 is your answer. In other words, it's 23.11%. Okay? So you're right. You're going to divide. It's going to be the 95 divided by 411. And then you get the numerical answer. You convert it to percent. So you're converting a decimal at this point, this decimal of 0.2311, to a percent. And some of you guys may say, do I have to actually multiply both sides by 100? Or can I say n% and just move this decimal 2 spaces to the right? You could just move it. You're fine.
Is it wrong to answer 23%?
Well, you know, you bring up a very good point. On the worksheets, they didn't tell you where to approximate.
12 is his round answer to 2 decimal places.
Yeah, but that's number what?
That's this one.
Is that this one? Oh, no, you're right.
Oh, no.
No, you're absolutely right. Number 9 is rounded to 2 what? Decimal places. So what they really mean, okay, good. You have to round this to 2 decimal places. What is 2 decimal places anyway? I think were they very clear? Well, it depends. Round your answer to 2 decimal places. What they mean is this. The question is a percent question. Okay? So 2 decimal places is tenths and what? Hundredths. This is the second decimal place. So they wanted you to actually not round it to 23%. They wanted you to put 23.11%. And that was in the instructions. Now, would it be wrong? It's wrong in the sense that you didn't follow instructions. You know, then you say, okay, that was wrong, because they wanted you to round off to the nearest hundredths.
I used my calculator and it just showed me 23%.
Because your calculator's set to that accuracy. You know, and that's where it was. It's your calculator is set to a whole number accuracy, so it's rounding off already. So, you know, like I said, keep in mind you don't know where they're going to ask you these questions. It's not just a test that you take here. It could be anywhere. And they may have their feelings that, so if you give 23%, that might not be something that they, they'll frown at that maybe, So I think the safest answer is going to be go with what the instructions say. Or if it's money, you should always go where by default if it's money. Go out to the nearest penny, which is still 2 decimal places. It's money. So that's kind of what I know from experience. Like look at number 11. Bill, they have a bill for what? $357 to city services. The claim is the fire department received 24% of that amount. So notice what they're saying. This is exactly like what? This question here. Is that right? So they're saying here that the fire department receives how much? 24% of what money? 24% of that amount. What amount are they referring to? The 357. So this goes here. 24% of 357 will give me the amount that goes to the what? Fire department. So how do you represent 24%? Right? 24% is 0.24. So this is really a question that says, can you compute 0.24 of 357? Because of means to multiply. And what's 0.24 times 357? Again, I computed this all last night and gave away my work to charity. And I got last night $85 and what? 68 cents. So the fire department receives $85.68. And what you guys want to notice about this is, let's double check. Did they tell us where to approximate? No, they didn't, right? Number 11, they didn't give us a decimal place to approximate. So are we dealing with money? We're dealing with some money? So the safest assumption to make is to go out to the nearest what? Penny. Because if you actually look at your receipts, do they ever approximate, stop and think about this. You go to McDonald's later today, you buy lunch, costs maybe, I don't know, $5.68. Do they ever just approximate that to like $6?
No.
No? What do they charge you? They charge you down to the penny. So when you're working with the money and percent questions, you want to go out to the what? To the penny, because that's how the world kind of works. They'll go out to the nearest penny, right? They're not going to approximate it to some convenient number. So yeah, do the nearest penny, even though they didn't tell you where to approximate when it comes to money. Okay, you guys okay with that? Because like I said, it's not just me who tests you on these things, it's everyone else as well. Yeah.
Can we always approximate to the nearest penny?
From money? What do you guys know? What do you think the answer is? Yes. Okay? Approximate to the nearest penny when it comes to money.
Even if it doesn't ask us to?
That's exactly the point. It didn't ask you to. See, if you go to lunch to McDonald's, are they going to say, I'm making $6? $4. $12. They're going to tell you what? $85 and what? 68 cents. And nowhere in the menu did it say anything about approximation, did it? You guys notice that? $85. So you're going to deal with money, you're going to approximate to the nearest penny. All right, here we go. Now, this is what I want to warm up with, because what we're actually going to work with today is slightly different. We're going to work with a couple of scenarios. Here's what I want to show you guys. There's really 2 scenarios or applications of working with percents that we're looking at in this worksheet. Okay? We actually talked a little bit about it yesterday. Consider the sales tax. Okay? sales tax, and that's what's called an amount, is a sales tax rate times some amount. Are you guys with me on that? Just like a discount is some discount rate times an amount. So I'll put these two concepts here for you. So I have some discount, and that again is some amount, equals a discount rate times some amount of money. So we looked at this a little yesterday. Okay, so let's review a little bit, I guess, if we wanted to go with some concept like that. So yesterday, let's say, for example, what are you going to buy again? Let's say you purchase a suit for $1,050, in which a sales tax rate, and they don't always say rate, they may just say sales tax, of 7% is applied. Now they may not say directly what it's applied to, but it's applied to the amount. Okay, the question's going to be, how much is the total? Now, what do you guys know? How do you get the total here? How would you get the total amount? Right? Stop and think about this. What happens is that, isn't the total equal to what? Good, the original amount plus the sales tax. And I'm going to call this a sales tax amount. Okay, you okay with that? Why don't I call it a sales tax rate? Because you're not adding the original amount to a rate of 7%. In order to get the sales tax amount, you guys already know it's 7% of what? The original amount. This is 7% of the original amount. Okay, so let's make this really clear then. What I'm saying to you is that a total is an original amount plus 7% of the what? Original amount. So here's what you guys have to identify. In your question, and very often this is, because this is an algebra question, we create an equation to solve. So very often the question is what your variable is. Because what does it say? How much is the what? Total. That's the question that they're asking you, and that's what you have to find. You have to find the total. So one way we could go about this algebraically is to do what? Sometimes we say, let x be what? The total. Is that true? Now if x is the total here, this is what x is. That's what you have to find. What is the original amount? How do you know it's 1050? Anybody know? You guys want to tell me, how do you know that 1050 is your original amount? Well, this is the questions I usually get. Mr. Judge, I don't understand these word problems. How did you know the original amount was the purchase, was the price they gave you for the suit? Isn't that the total?
It says is applied, like the 7% is applied like already.
Yeah, I know. So what you guys really, there's some there's a little difference between these problems and the ones we work with, like the number problems where you translate that literally. In other words, you're going to have to use a little bit of what? What do we call it? Not just thinking. You're going to have to use a little bit of comprehension when you read. You know what I'm saying? That $10.50 is the cost of the suit or the purchase price of your suit. They're saying to you to apply a sales tax on what? The cost of the suit. So you also have to know how that works. So you're right, the original amount's going to be $10.50. This is $10.50. Let's see what this equation comes out to. 1,050. So if x is the total, this means that x equals 1050 plus 7% of what? 1050? 7% times what? 1050. Because of means times. Is that right? You guys okay with that? 7% of 1050. And again, what is 7%? How do you write 7% as a decimal? 0.07. So what you have now is that x is going to be 1050 plus 0.07 times 1050. Ladies and gentlemen, order of operation. This is why we studied order of operation. So what do you do first? Do you add or do you multiply? So multiply. Tell me what 7% of 1050 is. Now remember, is this money? Okay, so what do you approximate to, or what do you want your answer? This is your sales tax, by the way. What is the sales tax to the nearest penny? 7 what?
7350.
Okay, $7.
No, 73.
$73.50. Oh, that's right. We have an expensive suit, don't we? We're spending some money. We're looking good. Do ladies like that? They like it? They don't? They don't like a guy in an expensive suit? Spends a lot of money in a suit? You don't like that? How come?
Says that he's got a good job.
Okay, we'll do a car question. How much tax do you pay on a car? Too much money. Okay, the sales tax is $73.50. Is that right? Remember, you're talking sales tax. So they want you to actually approximate to the nearest penny? Of course they do. So what's 1050 plus the 7350?
1123.50.
Everybody second that? Is it 1123.50? Now this is what x is. Okay, here we go. Now let's talk about why do we bring up the model? The model here is important because what they're going to start to ask you now is a slightly different version of this question. Okay, so I'm going to erase this. Okay, you guys have this in your notes? See, they're going to give you other pieces of information now. Let me change this on you. And the model doesn't have to be 7%. It could be just n%. There was a homework question, a worksheet question. Well, let's start with that. I think it's number... All right, let's look at number 15. Number 15, I believe. We didn't do 15, right? No. All right, 15, I believe. This is the situation here. 15 says, it's on our worksheet, a tax-exempt school received a bill of $253.59. So there's a bill that they received. Let's call it the school bill. The school bill is 240. What is it? No, 15. $253.59. This is the school bill. Okay, I guess they say they bought educational software. Fine. Well, what else do they say? The bill incorrectly included a 7% sales tax. Okay? So in this bill, it includes a 7% sales tax. Now, do you guys know, is that a rate or is that an amount?
It's a rate.
Good. They don't always tell you it's a rate. But how do you know it's a rate? Because it's a percent. You guys with me on that? Okay, good. So this bill includes a 7% sales tax rate that corresponds to a sales tax amount. Okay, they didn't say that either, but that's how they're wording this. Number 15. Okay, how much? And this was incorrect, by the way. They should not have done it. So the question is, 15, how much should that school pay? They didn't say, but they want you to do what? Exclude the what? The sales tax. Exactly. Exactly. So what they want you to do is really, what are they asking you to really do? This is, let's just paraphrase this. How much should the school pay? You know, they're excluding the sales tax. In other words, I guess schools don't pay sales tax. So they incorrectly charged, the school. They included a 7% sales tax, which corresponds to an amount. That total was $253.59. Okay, you guys okay with this? This is how this is working. This number is the what? That's the total. Good. Where does that belong in your model? Where does that 253.59 belong? Isn't that right here? 253 what? 59. You with me on this? Do you guys notice that the sales tax rate is still what? 7%? So I'm going to replace this N with what? A 7. So this is 7%. And then what are they asking me? They're asking me how much is the what? Should they have paid? Should they have paid is the original amount. Is that true? So they should just say, they should have just asked us, what is the original amount? Do you guys know what the original amount is? Say no, but what are we going to call it? Good, you call it X. So if we call that X, let's see what we get here. And very often we'll describe this. Let X be the what? The original amount. If X is now the original amount, then what do we have? Let's see. 253.59 has to equal X plus 7% of what? X. And you guys know 7% of X is really 7% what? Times X. And what is 7% again? 0.07. Your algebraic equation really is 253.59 equals X plus that 0.07X. So if X is your original amount, the model gives us a very different equation here. Okay, in the past, look at the prior example. Prior example was much more straightforward. They didn't give us the total. They gave us the original amount. This time they're giving you the total, and they want the original amount. So you guys see how that model is so important and the key for you to set this up? And that's where people make probably the biggest mistake, is they're not familiar with a model as maybe we should say, like even applying sales tax to a purchase. Okay? So you guys want to become familiar with the models of how it works, even with sales tax. So here we go. Could you guys solve that for x? Take a look. What do you have to do to solve this for x? You have to combine what? Like terms. What number's in front of this x? 1. Can you guys tell me? What's 1 plus 0.07? Anybody know what that is? Think of money. If you had $1 and you're adding 7 pennies. Good, 1.07. Okay? And don't forget, on the left side, it's also equal to what? 253.59. So you have 253.59. You're going to now, in order to solve for x, you got to divide both sides by what? $1.07. Okay? And so you get x to be, if you do this arithmetic, x will be 253.59 divided by 1.07. Now I did my arithmetic homework last night. I did the division. You guys need to practice that long division here. Okay. Last night for number 15. You guys know what I got? X is going to be what? What did you guys get? $237. Okay, so appreciate the difference in kind of application here. $237 is going to be the original amount. Okay? So I guess the school has to do what? They'll pay the $237, and that won't include the sales tax. Okay, you guys okay with that? This is sort of what I think of as the flip side of, that model. What do you guys think? How do you describe the flip side? They're now going to give you the total and ask you for what? The original amount. Okay, so can I erase this? You guys okay with that? Okay. Now, let's think of a discount. Okay, how does a discount work?
Multiply that to the original amount.
Yeah, let's look at a discount. Get the picture from your buddy. Here we go. Let's apply a discount. Are we going to buy the red dress or the suit? I think we bought the red dress already, right? Oh, those numbers are pretty big. All right, let's see. Let's think. Let's just note, since we went over that yesterday, let's note the model. How does that model work? Right? Isn't the total equal to, and that's, by the way, total amount. Isn't that the original amount? Minus the discount? And that's a discount amount, by the way. You're subtracting an amount of money. And then, how do you receive the what? The discount amount. How do you make that computation? That is the n% of what? The original amount. So really this equation can be clearer if I wrote total amount equals the original amount minus the n% of the original amount. So the model we're going to work with here in a discount scenario looks like this. Okay? Okay, let's look at number 21. 21 is an example of this sort of situation. So let's write down 21. 21 on the worksheet is after receiving a discount of 9.5%. So I'm going to write down, there's a discount rate of 9.5%. Okay. On some bulk order of typewriter ribbons at John's Office Supply. So after receiving it, what does John pay? John pays how much money? He pays $5,249. Now here's the question. What was the price of the order? Before the discount. And on number 21, look at the instructions. What did they say in number 21? They gave us a break. You know what they said? Round to the nearest what? Dollar. They gave us a break. Okay? So in general, what do you round to? What do you round to? When you're talking money, the nearest penny. But what did they say here to you? Oh, so now whoever gave you the question, they want you to actually round to the nearest dollar. So what should you do then? Should you say, oh, Mr. Judge told me I always round to the nearest penny?
Eliminate
No.
the cent.
Exactly. So you're following the instructions, is that right? Okay, good. Well, here's kind of the information. They want to know the price of the order before the discount. What do you think that's called in our model? Is that the total, or would that be the original amount? What do you guys think? Remember, how many times do you read the word problem? Enough? Okay. So you got to figure this out. Let's see. We know what the rate is. What's the rate? 9.5%. John pays $5,249. Okay, I guess, what is that? What should that be then? Is that the total? All right, so $5,249. And then the rate was what? This is 9.5. And I guess they're saying, what was the price of the order before the discount? I guess that's the what? That's your original amount. So yet again, you're going to say, let X be what? The original amount. So if X is the original amount, I put an X here. I put an X here. So it looks like my model then becomes 5,249 equals X minus 9.5% of X. The word of you replace with what? Times. What's 9.5% as a decimal? 0.09 what? 5. So your algebraic equation really looks like this. 5,249 equals X minus 0.095X. Okay? So now I'm going to erase this side over here. You guys have this side in your notes? You don't have that box? All right, well, I'll try to write up here then. Okay. All right, let's take a look. What do you guys know you have to do here? If you're going to solve for x, which represents your original amount, what number here goes in front of x? 1. So if we combine like terms, right? 5,249 equals, what do you guys know? This is what? 1x minus what? 0.095x. You're going to have to do some arithmetic. Okay? What's the arithmetic going to be? 1 minus the what? 0.095. So if you want to do your scratch work, remember this. 1.000 what is that? 0.095. You're going to have to break out your algorithm of subtracting with decimals. You line up the decimals. You guys remember this? So you try to subtract 0 with 5. You can't do it. You got to borrow from the neighbor. What's the problem? The neighbor's broke. So this neighbor's broke. This neighbor has to borrow from this neighbor. That neighbor's broke too. So they finally find what? A neighbor that has some money. So they're going to borrow that. It's now 0. It's 10. You repeat the process. I can't do the subtraction. So this neighbor has to borrow from this neighbor. Can't. This neighbor buys from the next neighbor. That's a 9. This is a 10. Let's do the subtraction. Can't. Have to borrow from the neighbor. Neighbor has money now. What's 10 minus 5? 5. 9 minus 9. 0. 9 minus 0. 9. This neighbor's broke. That's 0. The point is, the answer is 0.905. So this is going to be 0.90 what? 5. In other words, 5,249 will be, don't forget the x, 0.905x. And again, how do you solve for x? Divide both sides by the 0.905. 0.905. Cancel. And ladies and gentlemen, this work's going to be 5,249 divided by that 0.905. That's going to be the value of x, which is what they're asking for, the original amount. It was the amount before the discount. Okay. I can erase my box now. Is that right? All right, here we go. Like I said, this work that you do is long division. This problem is 0.905 going into 5,249. Okay, if you guys remember, we said the other day, or yesterday, you're dividing by a decimal. Okay? What do you have to do with that decimal? Move it to the right how many spaces? Then you have to move this decimal how many spaces? 3. Fill in the blanks with zeros. So what you're going to have now really is a division problem that's 905 going into, it's really 5 million, I believe. 5,249,000. And that decimal is back here now. So you have some work to do. Okay, you got some work with decimals. This is number what, 21?
Yes.
Got some decimal work. Now, I did this last night while I watched the Dodgers lose. All right. What do you guys think? How would you start to do this? Yeah, what would you guys do here? Well, 905 doesn't go into 5. It doesn't go into 52. It does not go into 524. It does go into 5,249 though. Is that true? It goes into this number. Is that right? So how many times does 905 go into this 5,000? We're going to take a guess. A good guess is what? 5. Excuse me. Why is that a pretty good guess? Anybody know? Because isn't that almost 1,000?
Yeah.
So almost 1,000 goes in about 5,000? So we're going to start with a guess. This is how you do it. Question? No? You could try 6. What happens if you tried 6? Right? Maybe you say you got 905 and you're going to try 6. What do? 6 multiplied to 5 is 30. Oh, that's a 3. What's 6 times 9? Is that 54? 5,430? That's too what? That's too big. It's not what? 6. Is that true? It's really what? 5. So I want to say to you that how do you really do this? Sorry, that's not a 6. You start with maybe the 6. You start to guesstimate what might work. Okay, you go, oh, okay, this is about 1,000. Well, it's not quite 1,000. Maybe a 6 will work. 6,000 goes to 5,000, maybe 6. We've seen that 6 didn't work. But what do we know? That 5,430 is close. It's over. 6 is not going to work. The 5 will work, I bet, right? Now, 905 times 5, what's this? Is this going to be, what is it? 4525? So you get 4,500 and what? 25. And then you're supposed to subtract. So you got to know your long division algorithm.
724.
What do you got?
724.
Okay, we get 724. Does everybody agree with that? And what happens next? Bring down the 0. And you repeat the process now. You got to see how many times does 905 goes into 7,240. Is it 8 times? How do you know it's 8? You what? You multiplied. You said, okay. You said maybe that's a good place to start, right? 905 times 8. 8 times 5 is what? That 40. What's 9 times 8? Oh my God, look at what happened. You guessed pretty what? You were pretty good. All right, so you got a what, an 8? Look at this. 8 times 905 is what? 7,240, and you subtract, you get a what? 0. You guys already know. What happens if you do this process with 2 more zeros?
Bring them down.
You bring them down, but you're going to really end up with what? 2 zeros there. And is that to the nearest dollar? Actually, it is. So what's the original amount for x? Yeah, we'll put it right here. X equals $5,800. So guess what's the story? What was the price of the order before the discount? $5,800. That's the original amount. Remember, when they apply a discount, what are they doing? Where is it at? They're throwing away some amount. They're subtracting. So, just to let you guys know, this is how you work with the kind of scenario that applies to a discount, but you are actually trying to find not the total. You're trying to find the what? The original amount. So, what happens, in my opinion, in 110, you worked with the other scenario. They always gave you the what? The original amount, the discount rate, and then they wanted you to find the total. Do you guys know what I'm saying? They gave you the original purchase, the sales tax rate. They wanted you to get the total. So in 110, they worked one way. They want you to find that. And then they did a little bit of the reverse in 110. I know because I noticed it. But in 115, they're going to definitely give you both. This is now what we're working on is if they give you the total, can you find the now original amount? So they're working it a little differently. Okay, you guys okay with that? Any questions on this here? You sure? Okay, so I want you to look at this a little more general. We have two kind of situations. Okay? There's two situations that the last two examples we work with have really something in common, but they're also different. So I want you guys to kind of get used to this idea that in one case, we have a new amount. Who knows what that number is? And that is based on an old amount, okay? It's an old amount plus n% of the what? Old amount. This is very, very simple in a way. This represents what we call an increase. Would you guys believe that that's an increase? How do you know this is an increase? Because you're starting with the old amount and you're adding a what? A percentage of the old amount. That gives you an increase. This was your sales tax model, by the way. We could look at this model in general. Okay, and that's what we're going to do with the rest of these problems. Similarly, we also have a scenario that represents a decrease. You okay with that? And here's your decrease. The new amount, by the way, which will be smaller because it's a decrease, is still the old amount. Now it's going to be what? Minus n% of the what? Old amount. This represents a decrease scenario. So in some ways, I can say to you, this is a generalization of, if you want to think of it as sales tax or what? Discount. Okay, that's a generalization, and we work with this model all the time. Like for example, we'll see, probably not today, look at number 17. 17 says what? Stevie bought a stereo for what? $230, and he put it on sale at a store at a 65% markup. Now that's a markup rate. What was the retail price of the stereo? Round to the nearest penny. So what we have to look at, notice that, is this a sales tax question at all?
No.
Not at all. Is it a discount question?
No.
Not at all. You guys see what I'm saying? It's not that at all. Which one is this? Is this an increase or a decrease scenario?
Increase.
How do you guys know that?
Marked it up.
Okay, good. So what really happened? Stevie bought a stereo for how much money? $230. He put it on sale for what? At a 65% markup. What was the retail price of the stereo? What is retail anyway? Anybody know what's retail? Was what it's being sold for? Or is that what he bought it for? What are they talking about?
When he's selling it.
The amount before taxes.
That's not even, there's no taxes here. There's no taxes here. I don't know. We got to think about this. How many times do we have to read it? Enough. Stevie bought a stereo for $230 and put it on sale at his store at a 65% markup. What was the retail price of the stereo?
What was the markup? It means that the retail price went up.
Yeah, what does markup mean?
You increase the price like
You increase the price by what? In this case, 65%. So the question I have for you is, it's 65% of what? What is retail?
Original amount.
What was the retail price of the stereo? Well, here's what I'm saying to you. Is this the forward or the backward scenario? In your model. Do you guys know what's going on? No? Here's how this works. The retail Isn't that the new amount? The retail is going to be, what's the story? How much did he buy it for? He bought it for $230, and then he marked it up at what? So that's 65% of what? $230. Let me make sure we're in range here. So retail is really the price after the markup. So he purchased the stereo for $230. He marked it up at 65% of what? $230. Is that number 17? Okay, you okay with that? So this is what he bought it for. He increased it by 65%, and that's what he's going to get for it. So the retail is what they're going to sell it for. The store bought it for $230. Okay, so then this becomes $230 plus 65% is really what again? 0.65 of means times that $230. This is called the markup, by the way. This is the markup, how much they increased it by. And what's 65% of 230? 149.50. 230 plus 149.50. So what does that give you as a total? Is that 379.50? Okay, so the retail, or what he sells this for, this is number 17. He's selling it for $379.50, and that's after a 65% what? Markup. That's how stores work. So the retail price. What's the story though? How do you guys remember this story? What do you never do? Never buy what? Retail. You guys ever hear that story? Never buy retail. Because that retail includes a markup. A percent of, what's wholesale? Huh?
You're eliminating the middleman.
When you're eliminating, I guess, yeah. So this would be your wholesale value. Because he bought it wholesale from where? Who knows? That's what he paid for it. At his store, he includes a 65% markup. 65% of that wholesale value, which will give you your retail. Okay, we'll do some more tomorrow. Work on your worksheets so that if you make mistakes, you can see where your mistakes are. Let's go over some of these here. Okay, so let's go over some of these problems that we've been working on. Let's see, this is up from the worksheet 16 and 18. So we have Gloria received a 4% raise and is now making $24,960 a year. What was her salary before the raise? So this follows that model we talked about last time, right? When you get a raise, do you guys remember? Are you getting more money or less money? More. Now, when they talk about raise, it's an additional amount of money, right? And it's actually, in this question, it's 4% of some other dollar amount. So if you remember what we looked at last time, we said that this is probably going to be the what? The original amount, right? 4% of what? An original amount will give you some new value. Okay? Some new value, and notice this is an increasing situation because when you get a raise, they increase your salary. Okay, you guys okay with that? So we kind of wrote that format down last time. But notice here, in this model, what did they give you? They said she's now making what? $24,960. So if she's now making that money, was that the original amount she made or is that the new amount? New. Okay, good. So this is going to be what? $24,960. Now what is X going to represent here? Well, it's the original amount, but what was her salary before the raise? So this X actually represents her salary what? Before the raise. Okay, you guys okay with that? So remember, she had an old amount of money, original amount of money. She gets a certain percentage of that, and now she has a new amount. So you're going from an old value to a new value. Bless you. Okay, so in some ways we could say let X be her original salary. So X is the original salary, and if X is the original salary, you get X plus 4% of X. Now 4% of X, remember the word of means to do what? Multiply. And that should equal her what? New salary of $24,960. Okay? 4%, you guys remember, how do you represent 4% then? That's right, you got to convert that to a decimal, and you're on your way. X plus 0.04x is $24,960. Now you guys remember, you're combining like terms, right? What number's in front of that X? 1. Okay, there's a 1 there. So when you combine these like terms, what's 1 plus 0.04? So that would be 1.04 X equals 24,960. Okay, you guys okay with that? Now divide both sides by what? 1.04. And you notice you get X equals, do the division. We have the long division. So I did my long division last night when the Dodgers won. Okay. They won last night. So what did I get? What did you guys get? X will be, what is X? What did we do for our long division last night? Do you guys know? What'd you get? 24 what? Thousand. Okay, notice a couple of things here. By the way, just to kind of remark about your division. You guys remember the division you're really going to do over here is that 1.04 has to go into what? 24,960. If you guys remember, just to remark again, you got this decimal here. You have to move it how? 2 spaces to the right. Is that right? So move this 2 spaces to the right. What do you do with the empty space? Put some zeros here. So just to kind of remind you guys that you really have 104 with your long division going into this 24960 with 2 more zeros. Oh, that's 2 million. So anyway, this is the division you'll be doing for your long division. Okay, so just to kind of remind you about the work that you do here for this. So it's good to dig out the algorithm. You'll find that it's 24,000. So it actually works out really nice for you. Okay, you guys okay with that? Okay, so anybody have any questions on how you set that up, the concept? You sure? What did we say X was again here? What was the original amount? She made 24,000? Right? This is how much she made, right? Originally, that was her salary. So I just want to say, by the way, what if they asked you, let me erase this. You guys have that in your notes? Right? You guys have that? You want to take a picture of that? No, I'll get out of the way. I don't want to be on Facebook. Okay? All right, here we go. All right, I'm going to erase this. I want to remark here that this process gave you the original salary. Is that true? Sometimes I want to say that, give you a note on this worksheet, they may ask you this question. They may say, let's note, can you deduce what was the amount of the raise? Sometimes they ask that question. Okay, they're not going to ask you necessarily what was her original, salary. They may want to know how much was the raise. What do you guys do? Right? You know the raise was given to you in terms of a rate, 4% raise. That's not the answer. They want to know the what? The amount of the raise. How do you guys think you could deduce the amount of the raise? What portion? Okay, you're right. Just to kind of point out, isn't this the raise right here? Isn't this portion here the raise that I'm looking at? It's 4% of that original salary. Or it's 4% of what? This was $24,000 we found out. So you can answer that portion by saying, well, you know what? The raise is 4% of $24,000, in which you can compute that, by converting this to a decimal multiplying. So you can say, oh, can I just write this as 0.04 now times that 24,000? You can, so you do more arithmetic. But what might be a little easier to do? Exactly. Go back here. This is 24,000, right? So if you notice that I had $24,000 originally, or she had this. 24,000 plus the what? Plus that raise, she now makes how much money? 24,960. You guys with me on that? You guys see what I'm saying? She has a 24,000 original salary plus the raise, gives you that 24,960. Is that true? Yeah, I guess so. Okay, can you guys solve for the word raise? How do you solve for raise? Translate. In other words, isn't the raise equal to? Yeah, what's the raise going to be? All right, 24,960 minus 24,000. She's now making what? $960? Okay, so I just want to point out, sometimes they ask you just for the what? For the raise. Yes?
What if they're asking for the percentage raise?
They won't ask you in this question for the percent because they gave it to you. It's right here.
What if they did?
What if they did?
What if they didn't?
Oh, say that again. What if they didn't ask you?
Yeah.
For the
What
percent?
if they didn't give you the percent, but they asked you for how much the raise was?
They're going to need to give you a percent to ask you how much the raise is.
So you can't solve it without
You can't solve it without it. In other words, you have to have that percent to know how much the raise is going to be. They can't say, well, we're going to give you a raise, but they don't tell you how much. They're either going to give you, in reality, this question, they have to give you that percent. But in reality, when they give you a raise, sometimes they'll say, well, in this example, they gave you the percent, 4%. It could be 2%. It could be 1%. It could be 10% of a salary. So they're going to have to communicate that percentage of the salary. See what I'm saying? Sometimes they just give you an amount. They go, we're going to give you $960 what? More. But, yeah. Anyway. Okay. Excuse me?
So you said that they're gonna give me sometimes the amount of the raise. I said from that, could they ask how much of the percentage increase it was if they gave you the original like that?
No, because you know why? They won't ask you because they gave it to you already. Right? So they gave you this 4%. They're telling you, they're giving you a 4% increase. So they won't ask you that question because it was already here. Yeah. Okay, you okay with that? I think I know really what the question could be, what you might be thinking. Can I erase this? You guys okay with that? Here's what you might be thinking. Here is really the essence of your question. They may say to you something like this. I don't think, like on your test, I don't think they're going to ask you, but you could be asked a question like this. They can say to you, you know what? Let's say you originally make your original salary. How much did you make originally? Oh, let's say you make how much? Let's say you make $32,000 for your original salary, and they gave you a raise amount. You had a raise of the amount. Notice they're giving you an amount of, well, let's go back. Let's not give it to you that way. Let's say you have original salary of $32,000, in which after a raise, after a salary increase, which is known as your raise, right? You now make how much? How much do you now make? $35,000. Then they're going to say, what was the percent increase? And that was kind of like a Math 110, I guess, question. You know, there's some questions they ask you in Math 110. Do you guys remember these kind of questions? No? Got to get your money back then. Okay? So how does that relate to what you're doing here? Do you guys know? How does that relate to this? This model that we gave you, or I gave you. You have your original salary plus the what? Plus the raise. So go back to this model. You have the original salary plus your raise. Is that true? And what should that give you? Does that give you the new salary? Is that true? So what was the original salary here going to be? $32,000. What's the new salary? $35,000. So what do you guys think the raise will be? What does that mean about the raise? Anybody can tell me what the raise is? What's your raise? 3,000? Is that true? Because you're going to translate, because you got an equation, right? You got $32,000 plus the what? Plus your raise is $35,000. Okay, so if we do some algebra and solve for the raise, okay, so you get the raise being equal to that $35,000 minus the $32,000, and you're right, you're going to get the raise being what? $3,000. So you got a $3,000 raise. You okay with that? So I think this is kind of the essence of your question. This is the amount of your raise.
Can you figure the percent out that way too?
Well, that's what we're trying to figure out. Now, how do you get the raise again? What was the raise? It's n% of what? Of the original. Is that true? So, if I know the raise is n% of the original, oh, let's do this. What should we erase? N% of the original. How about if I erase the original question? Okay. And here's what I'm saying. Here's the raise portion, right? How do you get the raise? Remember that raise is based on, in this example it was 4%, but I changed the question. It's n% of your original salary. So, that kind of question, you're going to have to know what? What do you guys need to know? What was the original salary anyway? $32,000. So this was $32,000, by the way. And how much was your raise? $3,000. So you have an equation here that says 3,000 is n% of 32,000. So I solve for this is just like that n%. This is just like your certain type of percent questions. You solve for n% by dividing both sides by that 32,000. Is that right? So this cancels. You end up with n% being 3,000 divided by that 32,000. I think this is the essence of your question. Okay? Now, here's the deal. Let's finish this off. Well, what do you guys get? What do you guys know? This means really n% is, do you guys know how to do this division? Shorthand? It'd be 3 over 32. Good. So what do you guys get when you divide 32 into 3? Right? What do you guys notice? You got to put a 0 here, right? Because 32 doesn't go into 3. 32 doesn't go into 30. How many times does 32 go into 300? Not 10 times, because 10 times 32 is 320. So it has to be what? 9, is that right? So what's 9 times 32? No, 108? 9 times 32? Do the arithmetic. 9 times 2 is 18. Is that 288? You guys have to check my arithmetic. Is that true? Is it 288? I think it's 270, right? Plus 18. Okay, then you got 12. Bring down to what? 0. 32 goes into 120 how many times? Not 4, because that's over. So it'll be about 3. So the problem is, this is going to keep going probably. That's a blank space here, 0. Let's stop about right here, tenths, hundredths. We're going to approximate this to the nearest hundredths. The point being that n% is approximately 0.093. What does this represent as a percent? You can multiply both sides by 100. That was true. I'll move the decimal 2 spaces to the right. In other words, n is going to be what now? 9.3%. Okay? So if n% is approximately 0.093, n will be 9.3%. So that's your question that you changed on me. You said, wait a minute, what if they ask for the percent? If they do that, they had to give you the old salary and the what? And the new salary. Okay? And this is what I'm saying back in math, whatever class that was. Math 110. That, go back over here. Can I erase this? You guys have this here? Back in Math 110, they probably gave you a formula. You know, you guys remember this formula? They give something like this. Old value plus what? N% of old value equals new value. Okay? So they did some algebra and they translated this what? This situation. So you had the n% of an old value is some new value minus the old value. And then they divided by the what? Old value. Okay? And they got a relationship that n% is really found by taking the difference between the new and the old, and you divide it by the what? The old value. Okay? They called this a percent increase because you are going from a smaller value to a larger value. The old value is smaller than the new value. So back in Math 110 or whatever it was, they called that percent increase, and that's the formula that they gave. Increase. So what I'm saying to you is, this is exactly what we just did. But we did it a long way. Okay? So if you took that new salary of $35,000 minus the old of, what is it? What was the salaries? $32,000. You got the difference of 3 divided by your old salary of $32,000. So this is the same relationship is what I'm saying. So that's kind of what they gave back in Math 110. You know, today we're giving you a different version of the same story, but so yeah, so be careful when you ask some of those things. Be careful that you don't, I mean, you might take yourself out of the course. That's okay. You know, we can still do this, but that's where this comes from. If they want you to find the percent increase, they got to give you 2 values. The new salary and the what? Old salary. Yes?
So that's not the same as like is over equals percentage of.
Oh, maybe. Who knows? Who knows? Yeah, I know. This is algebraic. That other's like more of a gimmick. And and some of the gimmicks I'm not aware of. Yeah, this is the algebra of it. But anyway, okay. Can I erase this? When you videotape, you can't use all the boards. So anyway, so that's what I wanted to talk about here with this kind of problem. Yeah, if you start tweaking with everything, then you change things. But I don't think they actually asked you this in this worksheet, though. Did you guys notice that? They didn't ask you percent increase in the worksheet. You also have a percent decrease, by the way. And so this is actually a percent decrease. Okay, is it a decrease? Well, let's see. No, it's an increase. Sorry, I was going to give you a decrease. We'll do a decrease though. So what do you guys know about this number 18? On Monday, an investor bought what? Shares of stock. Is that right? And on Tuesday, the value went up 8%. So if the value went up, is that an increase or a decrease? Is that an increase? Okay. And then on Wednesday, what did the investor do? He sold it at the higher value of 1620. Okay, 1,620. And they say, well, how much did the investor originally pay for the shares? So how do you think that, can we describe this in terms of an old-new situation, you think? What do you guys think? Can you? In other words, how does this work? The original shares, you're going to say, how much did they originally pay for the shares? The original shares, well, let's write it down. What they originally paid for the shares, how about if we say the old value, what you paid, plus what? 8% of the old value, because it increased by 8%, gives you that what? New value. Okay? So this is kind of where we left off yesterday trying to talk about this stuff. So the old value plus 8% of that old value, because it went up 8%, it's 8% of the old value equals some new value. In the language of the problem, though, they're talking about what? What's the new value? 1620? Okay. What's the old value or the original amount? We're going to call that to be x. So you're going to let x be the original amount so what that gives you is the original amount plus 8% of the original amount will be that new amount of 1,620. Okay, so notice how the model works. This works just like all the others. How do you represent 8% again? 0.08. How about the word of? What's that? Times. So you get an equation here that is x plus 0.08x equals 1620. It's the same situation. You're adding like terms. What number's in front of that x? 1. So what do you get? 1.8 what? X is 1620. Divide both sides now by your 1.8. What do you get for x? What does x equal? 1,500? Okay, good. Notice again, the work you'd have to do for division is 1.8 goes into 1620 with the decimal out here. You got to move this decimal. Plug in a couple of zeros there in the blank spaces. Your arithmetic is 108 divided by 162000 with that decimal out here. And you're going to get x to be what? 1,500. So the investor originally paid $1,500 for this stock, and I guess a day later it went up 8%, and the new value was 1620. Okay? So the original amount is 1,500. So notice it followed the same exact model. Okay, by the way, what could we call this portion here? I'm just curious. How much was the profit? How much money? I'm going to put a note here. Let's note. How much money did the investor make? I'm just curious. Let's do some critical thinking here. Let's note. How much money did the investor make? What was the investor's profit? If the original purchase of those stocks, he paid how much money? $1,500. 2 days later, sold for how much? $1,620. What do you guys think? What was the profit? Isn't that 1620 minus what? 1,500, and what does that give you? 120? So not bad for just waiting for what? A couple of days, I guess. All right, you guys okay with that? You just wait a couple of days, and what happens? Your money goes up. Well, hopefully, but okay. So this is number 18, and it's another increase situation. Okay, let's take a look at a decrease situation now. Okay, anybody have any questions on this before we go on to the decreasing situation? Okay, could I erase this? All right. Let's look at the decreasing situation.